Hello and welcome back to Math with Sensei Brian. This is my fourth video. Fourth video. And I'm Sensei Brian. I'm your math coach, your math host. And remember, if you like what we're trying to do here, please hit the thumbs up. Please hit the thumbs up and subscribe. It lets me know that at least what we are trying to do is reaching people and encourage me to do more videos. This is my fourth video in a series of 20. Okay, let's get started. Today's episode is exponents, which is also called powers, and roots. So let's get into it. Okay, when we say exponents or powers, it usually means a number times itself. That comes in very, very important in today's world, particularly, and we'll get into that. But as it stands, what I mean is this. We have n to the first power, which usually means n, because n times 1 was the multiplicative identity. There's that word again. Any number times 1 is itself, or n. Well, I just do this, or equals n, right? Now, n to the second equals n times n. There's two n's. N times itself, twice. N to the first equals n times itself once. N squared, as we call it, or n to the second, n times n. N to the third, or n cubed, means n times n times n. And that goes on and on and on. And I'll show you what I mean. And I'm going to use a very simple number that you will understand. And we'll get into this in our next chapter as well. But I want you to see this. Let's use the number 10. You've heard the term base 10. Let's go 10 to the 1 equals 10. 10 basically times 1 equals 10. Right? So any number to the first power equals itself, because you multiply it times 1 equals 10. Now watch this. Okay. 10 squared, or 10 to the second power, equals 10 times itself how many times? 2 times 2. 10 times 10. See, 10 times 10, 2 tens, 100. Okay, that's 10 squared. Follow it, because when you see this, with tens it's easy. Why? Because as you see, the zeros add up. 3 zeros to the third power. With tens, that's easy, right? That's why I chose 10. But if we choose any other number, let's choose 2 for example, okay? Real fast, real fast, real fast. We'll choose 2, let's say to the 4th. That equals 2 times 2 times 2 times 2. What do you think that is? Good, it's 16. You got it right. You got it right, right? Because 2 times 2 is 4, times 2 is 8, times 2 is 16. 2 to the 4th. 1, 2, 3, 4. It's not 2 times 4. It's 2 times itself 4 times, okay? That's different, okay? Get that right. 2 times 2 is 4, times 2 is 8, times 2 is 16. Basically, that's exponents in a nutshell. Now, as time goes on, you'll start to see numbers like this. Right? You can actually figure that out, right? X to the third plus x to the second plus x to the first. Anytime a number is by itself, it's considered to the first power, okay? So, well, we know x times 3 is x cubed. X squared. Now, it means nothing as it is. It's just variables. But when you put numbers in there, it means everything. So if x equals 2, right? Let's say x equals 2. Then you got 2 cubed plus 2 squared plus 2, right? So what? 2 times 2 times 2 is what? 8 plus 4 plus 2 equals 14, right? That means something when there's numbers in there. Those exponents. You've heard the term exponential growth. Well, anytime you multiply a number by times itself, that's pretty big. We saw what happened with 10. 10 to the second was 100. 10 to the third was 1,000. That's exponential growth. Okay, so let me go ahead on and get to the next part. Now, roots are important too. Remember those numbers we had a little bit earlier using the tens, right? 10, 100, 1,000, 10,000. Well, when you use those in factor of 10, we call those factors of 10, 10 to the second, 10 to the third. Well, whenever you're dealing with roots, you're actually going to go the opposite way, right? You're going to take the bigger number and break it down to its essential component. So whenever you see this, this is called a radical, R-A-D-I-C-A-N, radical, or radical, depending on who's teaching you. Okay. Anyway, when you see this divisor sign with like a V, right? That's a root bracket. You just don't know what root it is until you see a number in there. When it's by itself, generally when you see this by itself, this is what it means, square root. So this means nothing until you put a number in there. So if you say the square root of 4, right, per se, so what times what, or what times itself equals 4? That's kind of simple. What time what equals 4? Don't tell nobody I told you it was 2. So 2 times 2 equals 4. So the square root of 4, my friends, is actually 2. I'm going to use a different color since the black seems to be wearing out. Blue. Okay. Cube roots. When you find the cube root of something, let's use this number this time. Let's use 8. So you're basically asking yourself, what times what times what equals 8, right? Well, we know that 2 times 2 equals 4. Just by following that logic, 4 times 2 is 8. So 2 times 2 times 2 is 8. The cube root of that is 2. Okay? Now, I'm using easy numbers, easy to find. I mean, obviously, when you get to bigger numbers, it can prove to be a little bit more difficult. My purpose here is to show you what it is. So when you see it, you're not intimidated by it. To go into it can take quite some time to find. There's a method of extracting a square root or a cube root or a fourth root, because what happens if you find a number that's not a perfect square, like let's say what's the square root of 624? You might not be able to find that offhand, right? There's a method of doing it that'll get you close, but to get exact can take you a while. My purpose here is to show you what it is. So when you inbox me and you message me with G and say you didn't show how to do this, is simple. This is an introductory so you can see what it is and what we're doing, okay? As time goes on, we'll get into that, but I just want to get you down the road a little bit, okay? So the last one I'm going to do in this is the fourth root. This time we're going to use 16. Now I'm going to use a different number. Right? Now that's a little bit different. So what times what times what times what is that? Well, I know what it is because, I'm a teacher, haha. But the premise is what times what times what times what equals 81. When it comes to the fourth root, well, what happens if we stick 3 in? 3 times 3 is 9. Times 3 is 27. Times 3. Ooh, what do you know? Interesting, huh? Friends, kids, this is just to get you started, get you down the road. As time goes on, like I said, we'll get into this a little bit more. That's it for this. The next one will be decimals. Decimals are very important. As you'll see how decimals come into play, exponents will come into play as well, and I'll show you how. Remember, love each other. That's all we really have. Treat each other kindly. One act of kindness can change somebody's life forever. One act of kindness makes a difference. God bless you.